Good morning, everyone. I am Saloni Shetty, the Women Chair for ISHRE Mumbai chapter this year, and I welcome you all to the first training session for ISHRE Student Technical League. Today, we have with us Mr. Gaurang Patel, who's going to take the lecture on heat load calculations. That is the first step in this ISHRE Student League technical competition. So I want all of y'all, all the students to pay attention to what Gaurang sir is talking about. Ask a lot of questions because you're not going to get this opportunity again. And put up all your questions in the Q&A box. We may take a few in between the session and almost all of them at the end of the session. Aaron sir, do you want to say something?
Yeah, absolutely. Good morning, students. I'm very happy to see a fantastic response to ISTL this year. I think all colleges put together, we have more than 30 teams already. I think around that. I don't know the exact number, but it is a massive support to us by you all guys. And now it's our turn to ensure that you get a proper support in your endeavor to become a ISTL champion in your colleges, and then participate into the all colleges intra colleges competition which will be held later. As we have said that this competition makes you do a fantastic work in terms of your personality development, your presentation skills, your communication skills, but at the same time it's very very important that we are all technical guys and we need to be good in technical things, and this is the start of giving you inputs, and as Saloni rightly says, Heatload is a start of any project in HVAC industry. Every project which comes up starts with a heat load calculation, so obviously it's a very very important parameter. And we have a fantastic speaker out here, Gaurang. Gaurang is a very very senior person in ISHRE and has been working in various positions. He was earlier a part of a Ahmedabad team. Recently, he has joined very, very international, a very big firm of consultancy. He's heading that firm from Mumbai. That's our pleasure that we could get a person now in Mumbai who is of Gaurang's caliber. And for you all guys, he is also a technical head, the chair for a technical group which works on a district cooling system. So he's an expert on a district cooling system. We earlier had a district cooling lecture from him. It's a fantastic concept, not yet very popular in India, but in Middle East and other countries it's catching up. It is done very well, and in India it is catching up. So sometime maybe I will request Gaurang to touch upon, just give them an idea about what is district cooling is all about, and maybe if you guys want, we can have a separate lecture in coming day.
Sure, sir.
Yeah, thank you, Gaurang. And this is an opportunity. See, the heat load has to be viewed in a very different ways and methods. So today, I think Gaurang sir will cover most of the technical part of it. We will later do a practice sessions with the help of our young and energetic engineers who are participating. Like Shamir is there, Saloni is there, Vishakha, Sushant. There are about 8 engineers who will try to do an online sessions with you to do actual heat load, how to fill the form, how to pick up the parameters, heat loads and other stuff. So please understand a concept today. Please understand how the approach is, how the things have to be looked at, what are the important parameters which affects the heat load calculation, and so on and so forth. So I leave it into your good hands of Gaurang sir. Guys, I need to leave because I'm a panelist on another project which is right now going on for another chapter. So I will request your leave. I will join back as soon as that program gets over. And I wish you all the best. Enjoy the station. Thank you very much.
Thank you, Joshi sir.
Thank you, sir.
Okay, Vivek sir, do you want to say something before we begin with our lecture for today?
No, I think let's use our time, and
Okay.
we will start immediately. I think we
Okay,
can
Gaurang sir.
because we need to take a lot of question answers.
All right. So Gaurang
Yeah,
sir,
based
you
on
are up now. Please
okay,
go
Gaurang,
ahead
you
with
can
your
take over.
lecture.
Yeah, thank you, Saloni, thank you, Vivek sir. Good morning, students. Today we will be having our first sessions, as Aaron sir rightly said, will be on heat load calculations. One of the most important things, he has given my introduction in a different way, but I would like to introduce myself in a more relevant to you, because in fact, like I had done my bachelor's in 2002, and then after 5 years of gap, I had done my master's in 2007. I joined in 2007 and passed out of 2009. And at that time, while doing the post graduations, I was just sitting in the chair like where you are right now. I was among one of the student member of ISTL Ahmedabad chapter. I had listened to the people's, the senior peoples in the industries, and tried to understand these industries, HVC industries, because there is a vast difference between your books and actual practice. Okay, so I know what we feel well while sitting into your chair. Okay, so try to catch up the things, the practical aspect from various seniors guys, and this ISRE, I'm really thankful to ISRE because the ISRE has given me a lot of things, a big platform. I always say that whatever I am right now is just because of ISRE, because they had given a lot many platforms, lot many technical knowledge and everything that required our young engineers to grow further. Okay. So let's with this one. I start with the main topic of heat load calculations. So though is a virtual session, so it will be like not having like much interaction with you. But like I know that you are the from third year and fourth year students. I'm hoping that you are knowing about some of the psychometric properties. So what will be happening, like when we go ahead in the heat load calculations, there will be some psychometric properties comes into properties, and their definitions comes into use. Okay, so right now I'm assuming that you know that the psychometric properties. If not, you can always go back and you can check that one. Okay, so that will be there, and always like as RN Joshi sir said, like there will be our young engineers will be there for your support in the next sessions also, so we can take up that time also in more details. Okay, don't hesitate coming up with the questions. So what I've been trying to covering, like just a brief of psychometric chart and important terminology for heat loads and various parameters and its calculation base for heat load. See, I'm not going to cover the detailed calculations. I will be giving you a brief what should be considered as for a heat loads. Okay, so for a practical session for the heat load, we will be having a separate sessions. See, this graph you are had seen. I hope that most of the aware about this graph. And this a simple graph covers lot of things about the air property, and complete air conditioning business is runs on this chart only. Okay, like if I just put few lines here, these three lines are very important for us. The dB dry bulb temperature, okay, the actual representative of the temperature when we measure that one. Then second is wet bulb temperature, which represent the what amount of moisture in the air is, and relative humidity, which is again represent humidity only, moisture only, but it gives a comparative percentage of humidity in the air. Now let's come to a heat load calculation. What is exactly heat load calculation is? Okay, normally the figures, the term says heat load calculation. So we are calculating some amount of heat for the air conditioning world. So heat load is a calculation of quantity of heat to be removed from the specified area to maintain comfort. Okay, so right now we are more comfort with the cooling part because we are in a that part of the globe where we are not requiring heating, we requiring cooling. So here I am using word that heat to be removed from the specified area. If this is for heating area, like maybe I'm doing for Europe, I am doing for US or any northern part of the world, I will say heat to be added for the specified area to maintain comfort conditions. Okay, but as such, right now we are more comfort with the in our area we are concerned with the cooling one. I am saying here heat to be removed from the specified area to maintain comfort conditions. Secondly, that this also include calculation of amount of cold air supply and temperature of supply air in a specified area. This calculation also like because like you will be having one room, so what should be the amount of air I need to supply? What should be the supply air temperature? And this includes calculation of heat from the heat source, internal and external sources. Okay. Now let's come to a very first one. Whenever I planning to design a heat load calculations for any of the area, maybe like you can take up from your drawing hall itself. Okay, let's take a very small one. You will be doing for a small room of your home. So what will be the various source of heat? आपके घर के अंदर heat कहाँ से आ पाएगी? Okay, you can see the pictures, you can list out the things कि heat कहाँ से आ पाएगी. The first one is your घर के आसपास आपकी जो walls है. Okay, that walls will be the main factors where the heat will come out from. Okay, now the question also comes like the wall is how that wall is oriented. We will come to that particular one. Okay, then second is glass, because if glass is there, your window is there and it's a glass window, and you will be having direct sunlight coming in, that will be another source of heat. You will be having a floor and roof also, like those people who are having a top floor, they must notice in the case of summer that the roof one adds lot of heat into our room. Then the partition areas. What is partition is the room for which you are doing a heat load calculations. Maybe like you are taking your bedroom as a for a heat load one. So the room next to your bedroom, which is non-AC, okay, and the common wall between that one is the partitions, and all such areas. Okay, maybe there can be glass also, maybe there is a storeroom also. All that you need to calculate as a partition one. Okay, then there will be equipments in the room. You will be having computers, you will be having fan, you will be having lights, all other sources will be there which are having electrical loads. So what happens in an electrical one, that equipment takes a electrical energy, converts into the required energy. Maybe like if it is a like you can say like light is there, so that converts electricity into a light energy. Okay, it gives you a lux there. So that will be converted into heat, and that particular heat which is coming from that energy which is coming from the electricity comes into our room as a heat with the help of light one. Okay, similarly if you take a computers, so whenever you switch on the computers, computer requires the cooling also. So what happens, there will be a small fan into your computers which gives you a heat extract from that particular machines, so that heat adds into your room. Okay, then outside the occupants one, how many people are there into your room. Whether it's like as a bedroom, you can consider 2 people, because as a human being, our body temperature is what, 37 degree, 36.4, and what we temperature try to maintain is 24 degree. So the delta T of our body has an impact on our heat load. So we need to calculate the number of occupants into that one, and we will come into more detail what other parameter affects the occupants. Then outside air. So in your room there will be some leakages which we need to, that from there the outside air coming into the room, because maybe in case of summer when the outside temperature is 42 degree, and if that air comes into your room, that adds heat into your room. Okay, in case of Mumbai, the more challenging one is what, whenever the outside air comes into your room, it brings lot of moisture also. So that will be coming to picture which we need to deal with. Okay, and a process heat, that is more relevant with in terms of when we are doing a cooling for any industrial building. For example, I'm doing one small industrial shade where there are a lot, maybe I will say they are doing some precise machining with the help of CNC, and there will be having a multiple number of CNC machines are there. So what happens, like that CNC machines has a different load, and I need to consider that heat amount of heat released by that particular machines. Okay, based on the type of machines there. Maybe I'm doing some of the another maybe some industries where steam is comes into pictures. So I need to consider the amount of steam released into that particular area, and need to consider while doing my heat load calculations. So that all things are comes under the process heat. Okay. Now let's, one other important is like whenever we do a heat load calculations, we will do heat loads in the two form. First we will calculate the sensible load, and second we calculate the latent load. Now what is a sensible and what is latent? Okay, those students who had like a fair idea of psychometry and one, they are knowing what is sensible, that is what is latent. But like sensible in a more simpler way, if I can say that sensible load is what, the load which increase your temperature, the load which will increase your room temperature simply. Okay, so that is like wall, glass, Okay, what will happen in case of glass? The sunlight coming from the glass adds direct heat into the room, and that increase your room temperature. Okay, so all that parameters which increase your temperature are coming into sensible load. Okay, so wall, glass, floor, partitions, equipment, occupants, outside air, the leakage air coming in, and the process heat. Okay. And second is the latent one. Latent one is what? Like the load which adds a moisture into room. See, because like as a basics one, like for any comfort areas, we need to maintain two parameters. One is temperature and one is RH. Okay, and being a Mumbai guy, you knows very well what is the impact of moisture there. Okay, because like where I had been, I was from Ahmedabad, so I had seen the temperature of 45-47 degree. Okay, but we have a low moisture rate here. Okay, but like in when I come to Mumbai, the more challenge for me was what? The temperature is lower one. Maybe like currently the temperature is maybe around the peak one will go around 37 38 degree, but the moisture will be very high. Okay, and that moisture give you a discomfort. So as a cooling one, we also need to remove the moisture from the given room, and that's why like we need to cater all parameters which adds moisture into the room. So they are like occupants, outside air, leakage air, or leakage in a sense, air coming from the leakage, the process heat, for example, steam, as I said. Okay, these all are adding the latent load. Now what we'll do, while doing the calculations, we do a calculation for two forms. One we will do for sensible load, and secondly we will do a latent load. And then we will add sum of totals heat, and then we'll do a further calculations. Okay. Now we'll go for like how to take one by one. For walls, glass, how to calculate the heat coming from the coming inside the room. Now the more basics we will be using is like mode of heat transfers. I think like this is a very recent where you are learning one, because normally whenever I'm taking these particular topics, I have an engineer sitting there which are working in the industry for last 4 years, 5 years. So they sometimes have a question one like what is a conductance. But like I am very sure like I need not to go to a very basics one for you guys, because you are right now on a sitting in the books right now. Okay. So mode of heat transfer, the basic one is the conductance, which is happening because of the delta T. And the most important parameters for is the conductivity of the material. Okay, conductivity, area, and delta T. Second mode of heat transfer is a convection one, which is happening because of the movement of the particle of the substance. This will comes into picture with us. Okay, Q is equal to HA delta T. Okay, convection heat transfer coefficient, area into delta T. And third is radiations. Okay, now while studying into books, we have all like done the various examples and everything, and we know that when there is no pure form of conductions, no pure convections, no pure radiation will be possible. Always whenever you do any practical example, always this will be a mix of all these three. Okay, now one of the important parameters like when we comes into sensible load calculations is a U value. I think also this is I taken from the books only. Okay, whenever you are doing a heat and mass transfers your subject, this comes into one like U value, oral heat transfer coefficient. Okay, so what is that oral heat transfer coefficient? So for any surface where there is a combination of conduction and convections, okay, we need to find out the oral U value, oral heat transfer coefficient, that is called U. Okay, so like for example, here I will take an example of wall. Okay, so if you see wall constructions, you can see here like here we will be having this particular wall will be there, and on the both side of the wall there will be plaster layer, maybe like in the range of 4 mm the plaster will be there, and on the plaster there will be a the heat transfer first happens like maybe like this is an outside condition. The heat transfer happens first through your convections, because the hot air outside the your wall will have a heat transfer through convections. Okay, and that comes to your plaster first, and then it goes to wall, then again plaster, and then comes to your internal room surface. And in internal room there will be again to the movement of the air, the heat transfer into your room. Okay, so this is like practical scenario from like how heat transfer starts from the convection, then 3 layers of conduction, and again last layer of convections. Okay, so you can see here like outside one, so that is a resistance, heat resistance R0, that is convection heat transfer coefficient of outside wall. Then for the plasters, L by K1, L2 by K2 for wall, L3 by K3 for plaster. Okay, these all are the conduction parameters, and again the convection parameters for the inside surface. So the way you do a U value calculations for various in your heat and mass transfer, the simpler one I had done for here for the wall one. Similar we need to do for the all surfaces which comes like into like having a sensible heat transfers. So the overall heat transfer, the total resistance will be the sum of all resistance, and the U value is equal to 1 by R. And this U will be used for all your sensible heat transfer coefficient, sensible heat transfer amount. Okay. Now, where to get these various K values from for the building materials? Okay, now we come to a practical, but because it was like what is theory, well, we were knowing that how to calculate the U value. Now, question comes first one like when am I having a brick one? I will be having a RCC wall. I having a wooden wall. Where to get a K value? Okay, so the K value will be available from like these are the tables, and these property tables are available into like ISRE handbooks. Okay, so if you take any ISRE handbooks, and you will find the heat load chapters there, and heat load, there are all these calculation tables are available for the property of K values. Okay, for all various material. I had just taken the one screenshot, but there are like more than around 10 pages are there covering all kind of materials. So you will be given like for example, I just take one like masonry. So if I take a cement mortar, so they had given the density also, and the relevant K value also. Okay, and this K value you can use into that of your calculations. In some of the materials you will be getting directly resistance also. Okay, so then you need to take out the details from this particular take out the details for various material from this particular tables. Okay, and then you can calculate the U value for the given room. Okay, like these are the U value calculated for some of the standard frequently used materials for one like 8-inch brick wall, 4-inch brick wall, 6-inch RCC or 4-inch RCC. So these are the like standard figures. Like when we are working regularly in the field, these figures are with us always in hand. Now let's start. This was a basic one. Okay, now we start. If I have a like I started thinking of like I need to do a heat load for any specific room. What details I need? Okay, so I need to do a proper, because normally what happens like when you are working practically on a on your as a design engineers, your things start with the architecture plan. You will get a architecture drawing of any building. Okay, showing number of rooms and everything. Okay, so what my study starts with, so I need to list out some of the basic parameters for the building survey. So where is the building located? What is which city? What is the latitude? What is outside conditions? I need to list out this all these things. Okay, that has an impact on my heat load calculations. Second one is a building orientations. Whether the various rooms has what kind of orientations, whether they have a exposed wall, are north facing, south facing, west or east. Okay, this all direction has an impact on the amount of heat coming in because of the orientation of the sun rotations. Then building construction, the wall construction material, glass type, and construction material, because that has an impact on your U value. Then roof orientation, whether they have a flat roof or slope roof. Okay, so based on that flat roof or slope roof, there will be an impact on like how much amount of heat will penetrate through your roof. The shading, the around your building, what amount of shading is available? Maybe like if you have certain buildings, and like you will be having a 5-story building, and just next to that building on a west side there is a high-rise building of 20 floors. What will happen, like that small building get shading in case of the evening hours with the help of that tall building. Okay, and we can take a benefit of that one while doing the heat load calculations. Then type of use of the building. What is the use of building? Is residential building, is a commercial, hotel, office, okay, the data centers, it is a gym, is a pharmaceutical industry, because that defines activity in the area, and based on your activity, your body will release amount of heat accordingly. Okay, because when you're like in the sitting in the your classroom, your activity level is very low, only your mind is working. But maybe if I'm taking example of gym, so you are doing a lot of exercise there, and at a time we are liberating a lot of heat there. Okay, so that comes into pictures like with the help of the type of use of the building, and also other parameters comes also picture like amount. Say if I take an example of data centers. Okay, so when I say data center, the amount of sensible heat with the help of equipment is very high. Okay, if I take a pharmaceuticals, so in case of pharmaceuticals, I need to go in each and every room and see what is the process going on there, and as per that one I need to define my parameters. Okay, then number of occupants into that particular various rooms. Okay, type of activity of occupant, as I said, like connected with the use of building. Various equipment in the room. आपका जो room है, what are the various equipment in the room? Whether it's like office building, so how many people are there with computers? You need to list out that one. Okay, if you are going for like any other areas, like if you saying any pantry, so what are the various equipment will be in the pantry? Then outside air requirements. This is very critical one. Like as we go ahead, like we will come also knowing more about the importance of outside air, because in like case of COVID right now, if you see properly what this is, you should be in a well ventilated areas. You should not be into any confined areas. If you are in a confined areas, have mask, take all precautions. But if you are in a well ventilated areas, the chances of COVID goes down. Okay, so that ventilated is what? It is like you are having a sufficient amount of outside air coming in your room. Though that outside air adds a heat load in our cooling system, but that is essential to maintain proper indoor air quality. Okay, this is like big subject, indoor air quality. I think like we can as we go ahead with your course, we can cover that in a more details. And process requirements. Okay, so this is a initial survey you need to do, and then we can go ahead with the various calculations. Now the first thing, like I said, like latitude. Whenever you put down any city name, they are saying like what is the latitude of the building, latitude of that city. Okay, and that latitude plays very important role in case of your heat load calculations. Why? Because for that and for that why, we need to go back to our school time, because in the classrooms, like in the class of 5 to 7, we studied that then the earth is inclined at 4 degrees and it's spin there. Okay, so what happens, the amount of sun rays coming into any of the area, it depends on the city or area located on what latitude. Okay, so if it is like if you go to the northern hemisphere or southern hemisphere, that at that latitude the amount of sun rays will be very less, and when you coming to the like towards your equators, the sun rays and the heat effect is very high. Okay, and that's why the latitude plays very important role. So whenever we go ahead, the latitude comes into picture every places. Okay, and secondly, the rotation of the earth around the sun, that which brings the your seasons also. So these are the four extreme conditions for the earth around the sun. Okay, the June and December and March and September. Okay, so our seasons are depends on that one, and on which part of the earth, okay, you are, that depends, like either like in case of India, we have a June as a like summer period. At the same time, in case of other countries which are on the other part of the globe, has the December as a like summer conditions. Okay, so you will find this same thing into the tables when we go into various parameters for the wall and glass, and these are the basics for that one. Okay, the basics lies into your books only, guys. Okay, so keep that with you whenever you go ahead in your life. So the second one was the outside design conditions. Okay, so like every city has a different outside conditions. Whether, like for example, I had given two example, Ahmedabad and Mumbai. Okay, so Ahmedabad having a it is quite away from seashore, so it has a dry atmosphere. Okay, so they have like high dry bulb temperature and low wet bulb temperature. At the same time, when I come to Mumbai, okay, so the dry bulb temperature is comparatively lower one, but the wet bulb temperature is higher one. Okay, so the amount of moisture is very high, RH is very high while designing the condition into Mumbai. So whenever I'm designing my heat load calculations, I need to consider this condition first, because the load is coming, the room which you're cooling right now, it's getting heat from outside only. So that outside design conditions is the first parameters comes into pictures. Okay. Again, this outside design conditions for various cities you can take up from the ISTL handbooks. Okay. Also, like we have one more book, there is a ISTL weather data book that gives more detailed study of various cities. Okay. Then the inside design conditions. What would be the inside room temperatures? That will be like I had listed here in terms of the Fahrenheit, because why Fahrenheit? Because as such, like if you see, we have a lot of calculations based on Fahrenheit calculations. Okay. So right now both the things can be available, degree also, Fahrenheit also. So, but like when initially this all things started, calculations, heat load calculations, I think if you ask any senior persons, they always refer the carrier handbook. Okay, so that was the first one of the comprehensive book with all calculations and all understanding of air conditioning. Okay, and you can refer any of senior person in Israel or anywhere for working in HVAC industry. They must have that copy with them, and they will be using as and when they stuck up for any calculations. And that particular basic book was in Fahrenheit. So still today you will find this Fahrenheit uses of in the various calculations. Okay, so then you need to define your inside design conditions, whether what temperature you will require into your comfort areas. Like it's in like normal residentials, we design at 24, 25 degrees. In some of the like for example, I am doing for OT area. There's operation theater for any hospitals. Okay, there maybe I need to go for lower temperature. Why? Reason is like at that time the doctor who is doing the surgery, he need to be a complete grounding. He will be doing complete grounding there. Okay, so the person has real number of clothes. He has grounding, his face covered, hands covers. So whatever the heat released from his body is not coming directly into the room. So at a time, if you provide 24-degree, not be comfortable for the doctor. Okay, so we need to provide a somewhat lower temperature there, so that the comfort can transfer into his completely grounding body. Okay, and second one important parameter is, while they are doing operations, they have a very high amount of lights there. Okay, special lighting fixtures are there, and they are very close to the operating persons. So that also like they will be having a heat source just nearby them. So normally when we are doing that kind of applications, we have a lower set point temperatures. And if I like having any process requirements, so that also depends one. So you need to decide your inside design conditions. What is you require? Like you require 24, like as a comfort one, when you say it will be 75 55, that is your 24 and 55% RH. You need to define both these parameters, and that comes here. Like if you see here, like for example, I had taken this 73 55 here. So this will be like 110 is outside condition, 73 is room condition, and this is delta T. And similarly for RH, this is 24 and 55, and this is a grains per LB. There's your humidity ratio. Okay, for the given property, I had calculated the humidity ratio into grains per LB, and the difference of that one will be added, will comes into my room. Okay, as a moisture load. Okay, because RH is a percentage figure. Okay, that is not absolute, so I can't take a reference of RH as a difference of RH as a calculations. I need to find out the actual humidity from the psychrometry, humidity ratio, what we say. So that is a grains per LB. Okay, so That difference we need to calculate, and this grains per LV difference will be utilized everywhere whenever we go for the latent heat calculations. Okay. Now second one is comes into like outside air calculations. What amount of outside air we need to add into the room? See, as I said, like in case of COVID, they are requiring that amount of outside air we need to add into the room. Okay. So there are guidelines stating that one what amount of outside air you need to put in your room every moment. Okay. So there are like ASTRA 62.1 is one of the code. Our national building code of India, that is NBC 2016, is a national building code of India. They also specify the things, and ISA handbooks and ISA data books also provide this particular requirements, how much amount of outside air we need to add for various rooms. For example, if you say the office building, okay, so office building says that 5 CFM per person outside air, plus there will be like for amount of areas 0.06 CFM per square feet. So you need to calculate for all your areas what amount of minimum ventilation outside air you need to add into that room, and that comes as a heat load for you. Now let's we comes to like first parameters, the glass one. Okay. Now we'll go by various components how to calculate the heat. Till like we had taken like all surveys and everything we had done. We had defined the parameters. Now we'll go by one the various parameters for the heat load calculations. The first one is the glass. Okay, so just like there will be any glass into your room, what will be the how that heat transfer from that outside to your inside room? There will be two mode. One is the by radiations. Okay, so that will be like direct sun rays coming into your room, and that adds heat into your room. And second is your conduction, because glass is a like medium there, and outside temperature may be 40 degree, inside will be 24 degree, and there will be heat transfer. Okay, so there will be two type of heat transfer from the glass. So let's say we take the first one, the solar heat gain from the one. So at that time, what we need to do, we need to calculate the heat added with the help of the radiation of the sun. Okay, जो डायरेक्ट अपना जो लाइट रूम के अंदर आ रहा है, okay, उसके कारण जो अपने को हीट अंदर ऐड हो रही है, that we need to calculate. Now that depends on what? The amount of direct sunlight coming into your room or direct radiation coming into in room depends on what? It will be depends on your sun angle, okay, for that particular areas. So that depends on your latitude, where your city located, whether it is like close to equators, whether it is away from equators, okay, and that is defined by the latitude. So that latitude comes into pictures, and on based on latitudes we have a various tables, various studies done, and we have various tables where you can take the solar heat gain factor directly. So like here, like I had given equation here, like Q is equal to solar heat gain into glass factors. Okay, so let's first concentrate on solar heat gain. So solar heat gains comes from, that is basically is a value derived from based on the like orientation of the sun. Okay, and second is glass factors. So because your glass had certain properties, like you had seen your home glass, which is very common glass, is like 4 mm clear glass. Okay, but like when you go to any high-rise building or any office building having a completely glass facade, you can see a green building or blue glass. If you try to see closely that glass, it will be a thicker glass. Okay, sometimes a single pane, there can be a double pane, there can be like in case of glass there is variety of glasses available because of the that, and that has impact on your shading coefficient. The glass provides what shading. Okay, what happens in our if I just give you, I'm not going into like much on glass right now. I give you a simple example. In your home, you have a window, and in every house near the window there will be a curtains or blinds. Okay, why we have a only curtains? It is not a only for interior decorations. If it is for interior decorations, we can have a curtains on our wall also, but we are not having that on a wall. Okay, we are having only on the window only, because whenever you find that it is like if you're having a room into a east wall, okay, then what we'll do, in the morning that curtain will close, you will close that curtains to avoid this amount of sun heat coming from that particular window. Okay.
Gaurang sir, people have answered here for shading from sunlight.
Okay. So can you repeat, Saloni?
Yeah, they have written, Rutik Dua has written to shade, and Abdul Rahman has also written for shading from sunlight.
Yeah. Can you? Okay. I just need to see that one, like coming back to my original screen.
Saloni, you can take that question answer also, because that is regarding latitude and
Yeah, I was just
convection.
going to come to that as well.
Okay. Sure.
Yeah.
So we have two more questions, Gaurang sir. One is regarding the significance of latitude in heat load calculation.
Yeah. Okay. Sure. So see, that is like I'm coming up that particular one because I had just given you idea. The latitude provides a particular angles where that has a sun impact and sunlight coming in, and then based on the latitude, you'll find the outside temperature variation of the particular city. So if see the cities which are like like uh, 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 on 22-degree latitude, okay, they are having a direct sunlight and they are quite hotter than the if you go which is like 10-degree latitude or 5-degree latitudes, like that is like northern hemisphere. So they have outside condition lower one, so that impacts your outside conditions and then impacts your internal heat loads. And when I'm coming to more coming slides, you will get more idea for that one. Okay. uh, uh, so I can again take up that question again more in detail, because like there are some more tables are coming up into coming slides, so you'll get some more ideas what is the impact of latitude. The picture what I given you earlier one. Okay.
Gaurang, so there's one more question. Convection will occur through convection from air outside. Is it right?
See, that first will be your outside condition. If I take, so that heat from outside to the wall will transfer what through what, because there will be always to convection only. Okay. So the first layer what we'll find, it is always a convection one, that outside air movement. Okay. So that outside air has always a high movement amount of air, because of the outside air has a high velocity, and that first the heat transfer on the wall happens through the that hot air coming in the contact of your wall. Okay. There is a temperature is there, but that heat transfer occurs from outside to wall is one of the parameter added with the your amount of heat air velocity into outside the atmosphere. Okay. So that convection comes first, and that through convections, which is like a combine of like your hot air plus the movement of the air, that transfer the heat from outside to the your wall first. Then there happens the conductions, and then you come to inside room, you'll be having a low air movement into the room, and you will be having a that hot wall, and that air movement inside the room takes the heat from the wall and transfer into your room. Okay. So there will be like the first will be convections, then conduction, and then again convection, if I take from heat from outside to inside. Okay. So here also, like I had given an example of conduction, conductive heat transfer, that is overall heat transfer value, because that is a combined one, convection plus conductions. It won't be like purely conductions or purely convections. I hope I answered the question. Okay. So let's come back to again to this glass one. So like glass heat transfer, we will be having a two important parameters: solar heat gain one, which is a property of like where the location is, and second is the glass factors, which is how what amount of glass is there, what is the shedding factor of that glass. Now, how to calculate the solar heat gain through any glass? Okay. So there are various tables are provided into our standard data book. Okay. And which defines the amount of solar heat gain through any of the plain ordinary glass. So see, here the comes with the latitude. Okay. So you will find the latitude here. Okay. So the tables are given for various latitude: 10 degree, 20 degree, 30 degree. Okay. And for any of the locations which is coming in between, you need to just just do a calculation between the two calculations, and you need to derive the figures. Similarly, there will be second impact is a orientations exposed, whether it's a north exposed or south exposed, west one or east one. Because if it's a north glass, it will not have any sunlight there. But if it is a like east, south, and west glass, it will be having a exposed to sun at various time. East glass will be exposed to the sun in the north in the morning hours, and west glass will be having a sunlight on the evening hours. Okay, and uh, the peak time for heat load calculations, okay, is a 4 p.m. We always calculate heat load at a in the month of May at 4 p.m. because at that time your heat load, the heat coming into your room, is always on a peak one. Okay, so here the tables are given for like all your orientations, north, northeast, east, and everyone. Okay. Secondly, they had given the timelines at which time you are calculating. Maybe like for our case, we are saying like we are doing a heat load calculation for May for the May month at 4 p.m. But based on your application, you can check also whether I need to do a heat load calculations for 9 a.m. or 5 p.m. Maybe you are doing some buildings which is occupied after in the morning hours only. So you can do a heat load calculation for accordingly for the morning hours only. Okay. And third one is like this one, time of the year. Okay, which time you are taking as a peak one there. Okay, so maybe like for our case, like we are taking it as June as a peak one here. Like in the initial picture I have shown you that for peak location of the earth compared to sun. Okay, so that was June, and for same time, if I go for the same value or for the other part of other half of the world, is like south latitude one, that is December one. Okay, so you'll find that all these things are there, and here the importance comes into latitude, how that impact our heat load calculations. Okay. Then this is a glass shading factor one. What is the impact of the glass shading? Okay, so you are whether you are taking a normal glass, ordinary glass, which is a shading coefficient of 1, plain normal glass. Now when you go for special glass like double pane glass, which is having a 2 layers, you'll be increasing the shading coefficient. Okay, now apart from that one, you can have a one coating on that one, or you'll be having a blinds inside. Like if I take a normal glass which is has a shading coefficient we consider as a 1, and if I add vanishatory blinds or roller shade which covers complete glass, my shading coefficient will be 0.56. Okay, and I will calculate that shading coefficient into my calculation. So what will happen, like I will be calculating solar heat gain factors from this particular table, then shading coefficient from this particular table, and the area of the glass. If I combine that A into solar heat gain factors, area into solar heat gain factors into shading coefficient, I will get a heat for that particular window. Okay, so I need to do a calculations for all orientation glass, north, northeast, east, south, and all 8 directions. I need to do a calculations. There are more form of the shading coefficients are there, like you had seen some of this kind of features outside the building. Okay, so this what happens, like whenever we provide the inside blinds that restrict the heat coming in after the glass, but you can have also external shading coefficient. Okay, so that like this are the various examples, so that light can come in, because glass, one of the important uses of the glass is to allow the natural light coming in inside your room. Okay, so this external shading coefficient allows that they allow the lights to come in, but they will not allow the sunlight to fall on your glass. So whenever you are doing this one heat load calculation, we need to consider this external shading coefficient also. Then heat gain to wall. Okay, now again, like as like we have calculated again U value before, so like you need to calculate the U value for the your wall, because you need to see whether it's a normal brick wall, RCC wall, or it may be like certain times they have in certain of the area they go for the insulated wall also, like they will be having 2 brick wall and there will be insulation in between. okay, to just to reduce the heat loads. Okay, so there is a like people are trying to do a more energy efficient buildings also. So that way, like as based on your project construction, you need to calculate the U value, then the area of the wall, okay, and equivalent temperature difference. Okay, now this is a term like ETD, equivalent temperature difference, is like depends on what? It depends on your latitude, on where your location is, the wall construction, light or colors, and that matters one. Okay, and we have a standard tables for that one, and standard tables provides U value, value of equivalent temperature difference with the condition of 95-degree outdoor conditions, 80-degree Fahrenheit indoor conditions, 20-degree daily range, dark color wall, and 24-hour operations. They had given like this condition about these 5 parameters. Any deviation from this standard conditions, we need to give apply our correction factors there. So that correct how to apply that correction factors also, that the tables are given. Okay, so like this is a table for equivalent temperature difference. So like you can see here, like this is for 40-degree north. Okay, I had the screenshot what I had taken here is a 40-degree north one I had taken. Okay, you can see my arrow here. Okay, and here they had specified like 95-degree outdoor air conditions, 80-degree room conditions. Okay, 20-degree daily range. Daily range is what? Your room temperature and your peak, sorry, not room temperature, sorry, your minimum temperature of the day of the that particular area, and the maximum temperature. The what is the minimum and maximum of the that area? If I saying about Mumbai, so on a daily day, the peak day where you are doing the calculations, what is the minimum temperature and what is the maximum temperature? That is your range. Okay, so that's they had considered 20-degree for this particular table, and they had given the various range. So like you can see here the various expose directions, the timing at which you need to do a calculations. Okay, and they had given the weightage of the wall, what will be the density of the wall, because like whether it is a normal partition wall of 4 inch or thicker one or RCC wall. So based on the weight per square feet, you can you need to take the value from here. Okay, and for the correction one, this is similarly for roof one. So whatever is applicable for the wall, same is applicable for roof also, because roof also have a that heat transfer from the outside to inside. So this is a table for roof one. So exposed to sun, covered with some water, spray or shaded roof. Okay, there will be, you can have a like a roof with shaded also. So based on all these 4 combinations, they had given the table here. So from here you need to take the equivalent temperature difference, okay, and add into that particular calculations of UA delta T. So delta T is the equivalent temperature difference. Okay. Then these are the correction factors they had given. Like for example, this is a correction for daily range. Okay, I will go little fast because like correction factor for the daily range. Okay, so here they have given the like outside design condition for a month at 3 p.m. Okay, minus the room temperature. So that particular comes here. So what is the 3 p.m. Temperature minus the room temperature, and against that here the daily range, because we were having a 20-degree daily range. If I have a like area with a 60-degree daily range, okay, so what I need to do is like I will be going here, like for example I had highlighted here for 22-degree, so I am taking 22-degree daily range and 40-degree difference of the room and the peak outside condition. So my correction factor is 24. I need to add this correction factor into ETD, equivalent temperature difference. Okay, similarly, there are tables for change of colors and change of your outside and inside temperature, the 95 and 80-degree Fahrenheit what we had taken, that correction factors are also there. So you need to take that everything and need to add into ETD, and you need to calculate equivalent temperature difference for various uh, uh, orientations, the west, the south, the east, and north for given area or given locations. Okay.
So,
So
Gaurav sir, we've
yeah,
got 2 questions regarding the solar temperature. So, one is how solar heat affects when we use solar on building walls. I don't know what that means.
solar panels on building walls?
Yeah, I think it means solar panels only.
Yeah, so see, that becomes what that will be you are adding anything ahead in your wall. Okay, for example, I have a waste wall, and you are adding something to shade that one into a waste wall. Okay, so that particular wall act as a north wall, because north will not have any direct sunlight. Okay, so the north wall is what always considered as a shaded wall. So if you put anything additional as a shading, like maybe you provide us solar panels there, and you cover that particular waste wall with the solar panels, so that's waste wall you need to consider as a north wall because it's a shaded wall. Okay.
Oh, okay, sir. And then another question is, what is a daily range?
Yeah, daily range is what your swing of your temperature at a peak day means. Example, if I give you for example, we are doing a heat load for Mumbai on 21st May. Okay, that is we consider as a peak day for the heat load calculations. So on that day, what was the minimum temperature of Mumbai, and what is the maximum temperature of the Mumbai? Okay, that particular difference is a daily range. So in the night it goes down to maybe 26 degree or 24 degree, and it goes high on 42 degree. So that difference of temperature is your daily range. So for any locations, what is the temperature swing? The minimum and maximum is your daily range.
Okay, sir. And another question is, what factors to consider for considering maximum heat gain from glass?
What factors to be considered for?
For considering maximum heat gain from glass.
Okay, see, maximum or if I just try to understand, we never would like to do a maximize the heat load gain from the glass in case of the cooling, but like we try to do a minimized heat gain from the glass. Okay, for cooling areas, we do the same thing for maximizing that in the heating areas. So see, we need to if I come down here, the basic one. So to uh, play with the amount of heat coming in from the glass, we need to play with these three parameters: the area, the solar heat gain, and the glass factor. Okay, so area is like something you can if for example, if I'm working with the architect, okay, and if they can have minimized the glass area on west and south facade, that will always better. They can reduce the heat, because whenever you calculate the solar heat gain on west and south, this at this location it is quite high compared to the north and northeast area. Okay, so one is that one. So you can control solar heat gain area, the solar heat gain factors, the area, and glass factors. So, and secondly, you try to maximize the amount of glass on north facade. Okay, and the north, then second of was northeast, and then east, and then very less on south and west. Okay, so that will have a low heat gain from the glass into the area. And third one is the glass factor. There is a glass property. Okay, so glass has whether you're taking a plain glass, or like there are high efficiency glass are coming up, like you will getting two layer of glass. Okay, and there will be inside two layers, there will be some either vacuum or either argon gas are being filled up to increase their heat, to increase their shading coefficient. Okay, secondly, to reduce their u value also, because there will be a solar heat gain, and secondly the conductive heat transfer also will be there, which we are going to cover now. Okay, so these three factors you need to play with: the area, the location of the glass, that is solar heat gain, and third one is a glass factor. So glass factor comes with a shading coefficient also, and the glass itself also. Shading coefficient also, we can say giving this kind of external shading to the glass also, that's reduce the direct sunlight coming into your room. So you need to work on these parameters to reduce the heat gain from the solar glass one. So I think any more questions, Saloni?
Just one more. While designing for a building, we need to consider what range of temperature for day or month.
See, if you see these particular slides of mine, like we have like in case of standard conditions, like we are giving like ISRE as well as ASRE gives like outside design conditions for various areas. Okay, so like if I take here, like for example, I had given a peak here for Ahmedabad, I highlighted here. So summary is they had given 110 degree and 70 degree. So whenever we are doing cooling one, so we need to consider this as our outside conditions. Now if you are having something different applications, and then if you would like to go by month wise, okay, so we have a data available for month wise also. So like maybe you had some certain specific applications which is not round the year, and you would like to do design for specific month of that particular one, then this is for all yearly applications. We have like it's a weather data books which gives same peak. Okay, so you can need to take the data from that one. So in normal case, when I'm doing the cooling load calculation, we take this from our like data books, the temperature given for the peak temperature given for summer temperature when we are doing cooling one. If you are doing for heating one, we will do for the winter months. Okay.
So one more question. If we apply external shading on a west wall, can it be considered as a north wall?
Yes, it is like completely shaded, then it should be considered as a north wall. Even same thing is applied for glass also. If you are able to provide complete shading on your glass, okay, then like for example the way it is done here, okay, you can see here like this is like trying to cover the complete glass. Okay, so you can consider as a north one, because at that time the direct sunlight light is not coming to your glass inside the room, so there is no direct radiation is there, only there will be conductions, so there will be same as north one.
And sir, how to calculate U value for a wall with external shading elements?
See, as I said, like it is as a external shading elements. Okay, you are not having a direct sunlight coming on your external wall, so you need to consider as a north wall only. So the U value calculation is same for whether it's a north wall, whether it's east wall or south wall. Okay, only your ETD equivalent temperature difference will vary based on the orientation of the wall. So your equation is what? Area into U into delta T. So the U is common for all the wall. Okay, it is no separate method for north or south. Only you to see what is type of the material being used for the north and west wall. If they have a separate material, then you need to have a separate U value calculation. But they have a same construction, then it will be the U value will be same for that one. Only the your equivalent temperature difference will vary with the orientations. And if you are having a complete shaded on waste wall, for example on waste wall, you have having a some earlier I had given example, you are doing a heat load for a small building, four story, and there will be a high rise building just besides that one, which provides complete shading on your waste wall. At that time the waste wall becomes your north wall while doing the calculations.
You can continue with your presentation now.
Yeah, sure. Okay. I think like I'm happy to hear these questions because these are really good questions. Okay, keep it up, guys. Then heat gain through partition and glass floors. Okay, so now these are the like see I had said for glass there are two type of the heat transfer. One is like through radiation, and second is through that of conductive heat transfers. Okay, because of the glass property, the delta T between the inside and outside. So this particular equation, that UA delta T, will be applicable for all the partition walls wherever you having AC and non-AC areas जहाँ पे आपका partition है. Okay, for example you are doing any room और उसके बाजू में आपका storage area है या कोई non-AC area है. Okay, so that common wall will become as a partition. Your glass area which like आपका जो west, south, north सारा इकट्ठा होकर जो total glass area हो रहा है, that one for that area, then your floor areas, the floor, because like for example I'm doing a heat load for the 5th floor. Okay, there is a 4th floor below. Okay, and there will be a fifth one more floor above. So if they both floors are non-AC, okay, then I need to consider the heat load from that particular floor also. So they all are coming as a partition. They do not have any impact of equivalent temperature difference or solar heat gain factors. No south, no west, no north. Only the difference is we need to calculate the U value, the area, and delta T. Delta T in since what I had maintained my room as a 24-degree, and the outside temperature. Okay, the non-AC area temperature will be what? So in normal case, what we do, if I do not have temperature for non-AC area, we normally what try to do, we take a 5-degree lower than the outside conditions for the partition. Like we consider 5-degree lower than the outside conditions. Okay, so maybe like outside is a 40-degree, we consider that non-AC area as a 35-degree, and then calculate the delta T. Okay, but like for any industrial building when you are doing, so maybe like the area which is close to where I'm doing a heat load calculations, if it is a like process area and there is a high temperature is there, maybe like there are the temperature, there's something, some furnace is there, so maybe the temperature is 50 or 55-degree in that room. So I need to calculate delta T accordingly. If there's a colder room, okay, like there is a cold storage is there, okay, so that gives me a positive impact. I will be having a minus delta T. So वो वहां से मुझे cooling भी transfer करेगा. I need to calculate the U value for the insulated panel for the cold storage. So that is, these are the simple, like the partition, the glass, the floors. You need to see, and it will be simple your heat load calculation, that is UA delta T. आपका overall heat transfer coefficient area into delta T. Okay. Now the third, next one comes is the heat gain to equipments. Okay, what are the equipments we are having? So the first one is will be having the basic one is a light. Okay, so what are the light? I need to the heat, because of the light I need to calculate. Okay, so the amount, like you can calculate like in terms of the normally what happens, like we have having a certain parameters into guideline. Certain areas requires watt per square feet. Okay, 1 watt per square feet or 1.5 watt per square feet. And if I go for energy efficient building, we try to lower the watt per square feet for by lighting, because that have a power saving in AC also and light also, and that can be maintained by the architect with the help of the glass again. So that will be like if I'm going for 0.7 square feet per 0.7 watt per square feet. Okay, so I can use the equation is equal to Q is equal to area into watt per square feet, that is 0.7 into 3.4. Okay, similarly for equipment, so this 3.4 is your conversion factor from watt to BTU per hour. There is nothing major sciences here. So like this is a, like if you see the area into watt per square feet, so it gives me a watt, and by multiplying by 3.4 I'm converting it to BTU per hour, because what we do, we try to calculate heat loads into BTU per hours. Some of the softwares do calculate heat loads into kilowatt also. Okay, some of the those who are using SI methods for heat load calculation, they do a kilowatt basis. The load is they give a heat load into kilowatt, but ultimately there's a unit of heat load only, heat only. Second is equipment one. What are the equipments you are having there? Okay, so like for example, you are having a printer there, you are having computers there. So that all equipment into 3410, same factors from here to here. Okay, and like you need to be very cautious when putting the process load, what amount of heat is coming there, because for example, I say a mechanical motor is there. Okay, there is one equipment is there having a 5 kilowatt load of motor. So what happens, I should not consider that 5 kilowatt, because what do motor do? Motor converts electrical energy into mechanical energy, and that inefficiency of that one is added as a heat into atmosphere. So if I say the motor efficiency is 80%, so what happens, the out of 100%, 80% of electrical energy has been converted into mechanical energy. The 20% is as wasted as a heat. So I need to consider 20% of the motor power as a equipment load for the heat load calculations. Okay, so that process load, you need to be very cautious what amount of heat load comes into our atmosphere. Okay, then heat gains to the people. I said like there are like heat gains to the people is depends on your type of activity or applications. Okay, so whether you are seated at rest, you are normally sitting in the your school or college, you are normal standing and walking into your departmental store, okay, or mall, or you are doing like some having like you are doing for any factory, light bench work factory. Okay, so these all are activities are given here, and on based on activity they had given your BTU per hours and BTU heat liberated from the persons. Okay, so that is like they had divided into sensible and latent form also. So they had given at a various room temperatures, room tribal temperature. So what you are giving, like normally we are keeping it 75 degree Fahrenheit. So if I'm like considering college time, so it will be 240 as a sensible and 160 as a your latent one. Okay, BTU per hour from a one person's. So I need to multiply this one with the number of occupants. Okay, and this whatever figures is given here, like it covers the your radiation from the screen, because you are a high temperature, you are heat source for them, because the room temperature is 24 degree, your body temperature is 36 degree. Okay, then convection heat transfer by the breathing, you are taking your breathing also, so you are taking breathe in and breathe out. Okay, so that when the you whenever you breathe out, the coming air out is a high temperature one. Okay, and that breathing out comes like as a like latent load also, because whenever we breathe out, the air will be like coming as a like some moisture also, depending upon your activity. And third is your evaporation of the moisture from your स्क्रीन, आपका जो स्किन है, जहाँ आपका जैसे नॉर्मल बैठे हुए तो आपके स्किन पे पसीना नहीं होगा, बट वेन एवर डूइंग सम लाइट वर्क और डूइंग आप जिम में कुछ काम कर रहे हो या ऐसा कुछ है, so you'll be sweating also, so that also comes into as a load to the AC. Okay, AC में आपको पसीना नहीं होता है, but your air conditioning system takes that particular load into that one. Okay, so that like you need to from this table you need to take the sensible and latent load for the occupant, and you need to multiply with the number of occupant and take into calculations for sensible and latent both. Okay, till date we had just come to like comes up to a latent load. Okay, Sulonis, I'm sorry, like as I said earlier, like I will be taking taking some more time because this is like quite elaborative subject. Okay.
I have to. So
Gaurang,
you people.
Gaurang,
Yeah, yeah. Yes, Yogi.
Gaurang, when you talk about heat gain through these equipments, can also guide him about the server and UPS and battery load, what he should consider.
Yeah. See, that's what like if I like we can have like for equipment, various equipment, like also if you are not having a details available with you. Okay, so we can use the data book again, because that have tables for various equipments also, and for the servers and other things, like again like if you go for servers. Okay, so server has certain racks. Okay, server is something like as you go make like your computer has, your computer what do they chips are there, and that for chip cooling they are doing a throwing a heat out. Similarly, when you are having a server rooms, okay, so server rooms take certain energy to do the processing. Okay, and they liberate, there is no like fundamental like motor which converts electrical into mechanical one, so that heat comes into your room only. So like if you say any of the data centers, like nowadays like we are going major and majorly online activities, and they are backed by the data center one. Okay, so that data center servers are like having processing countries to the data the processing they are doing, and they are taking the electrical energy for data processing. So they after processing it one, they adding heat into your room, so that also like your equipment loads are there. So yeah, you can like for more elaborately on equipment loads one, like we can refer that tables also, and like we need to like for data center one, like we need to have a like complete details study, like in terms of like what amount of type of rack and everything we need to consider, like it is like what is the rack capacity is like 3 kilowatt per rack, or because they have a various configurations. So we need to have a detailed study in terms of the equipment loads while doing data centers and other things.
Yeah, like
Also, like
if you have,
yeah, Vivek.
uh, Yeah, if you have like 4 kilowatt per rack or maybe 6 kilowatt, so they should take 20% as a heat gain, or they should take more than that.
So, in case of as I said, it is not like that of the mechanical equipment. Okay, so where only 20% will comes as a heat load, and the remaining they are going to convert into one. So it will be we need to add. Uh, yeah,
Yeah, continue, Gaurav.
yeah. So we need to add the equal amount of heat. Like if I'm saying 3 kilowatt per rack. Okay, so and there are 30 racks, so I need to multiply 3 into 30 racks, and 90 kilowatts will come into as a load for the rack. Okay, because there is complete energy will be converted into heat in only.
Right.
And if you are taking the battery one, okay, so the battery also liberate the heat. So you are doing some cooling for battery rooms. Okay, so that equipment, each equipment, right, that as of now I'm just taking as a generalized one because of the limitation of the time, because for each and every equipments, okay, you need to see the type of use. Like whenever I say process load, okay, so we need to be very cautious, try to understand the equipment and try to put into the equipment load sheet. Okay, thank you everyone. Let's catch you again tomorrow at 11 o'clock. All right,
Yeah.
Saloni, you can just check with faculties also. I think that will be very okay to students. Okay, at 11 o'clock.
Yeah, thanks.
Thank you.
Yeah,
Thank
and
you all the students for joining us today for this session. And I am hoping to see maximum of you all tomorrow. I mean, actually, all of you all as much as possible. But yeah, I hope you all learned a lot from the slides that have already been showed by whatever Gaurang sir has explained. I want you all to just go through it, revise it in your mind, and ask whatever questions you all have tomorrow. We'll begin with a few questions in the beginning, and then we can continue the presentation from where Gaurang sir has left off.